Good morning, class. Many of you have done most of the work correct, and there are a few questions. So that's good. And, make sure if you're not understanding, make sure you ask questions. Now, if you think you would benefit from having a day of just practicing questions, let me know, because I was thinking about maybe we can set aside this Friday and maybe next Friday to just have a video conference to answer questions and just exercise so you can practice very particular exercises from that week. So if you think that's a good idea, just let me know via the group chat or private chat, and we can maybe switch Friday's video to just a lot of exercises, but allow you guys the time to ask questions via Teams or Skype or whatever. And also, I want to congratulate you guys. Most of you are doing the homework well, and you're doing it, turning it in on time. Make sure you send it in. It's heavily weighted for the fourth quarter. If you don't turn in a single homework, your grade will drop. So if you have emergencies or you're sick, let me know ahead of time if possible. Otherwise, repeat offenders will get an email sent home. Make sure you do the work, please. Today, we're gonna finish off 5.2, which we began on Friday. Now, 5.2 in the beginning, it's just the rules of exponents. Today, we're gonna go over the properties of radicals. And remember, you can change any radical expression to a rational exponent. So that sometimes it's easier to work like this. Sometimes it's easier to work like this. And once you practice, you'll get to know which one it's better to work, is better to work with. Now, the basic two properties of radicals, the first one is the product property. It says that the product of two numbers to a root n, or nth root of something, is the same thing as, I copied the exact same thing, as the square root n of the first times the square root n of the second. Okay, so what this means is, for example, when we were simplifying roots previously, again, I don't know why they put this chapter after the other one, but some students, managed to say, for example, square root of 32. Some students said, Profe, but you can break this up into 2, square root of 16, square root of 2, and the square root of 16 is positive negative 4 times square root of 2. That is this root simplified. Pretty much it's the exact same thing. You're breaking this product, and again, 32 can be broken down into its factors. You could have 1 times 32, 2 times 16, 4 times 8. So again, you can use whatever factors you want to break, and you can break it down into multiple factors. That's fine. If you do the tree that I taught you guys, you're going to end up with this pretty much automatically. So if you want to do the tree, just go ahead and do the tree. Now you'll see why we want to do this. Let's say, for example, I'm multiplying two roots. Let's think. Let me see if they give me an example here. Well, no, let's do the one that's in the book. Example 2. It says cube root of 12 times cube root of 18. Now notice the root has to be the exact same value for this break to happen. You cannot multiply them or break them unless the root is the same, at least what's on the inside, okay? Now, 12 does not have a cube root. 8 does not have a perfect cube root. Okay, again, we're looking for perfect cube roots. If not, we just leave it expressed as a radical. So the 12 does not have a cube root. The 18 does not have a cube root. When you multiply them both, you get the cube root of 216. And when you plug that into your calculator, you get an answer of 6. So again, we're simplifying these two expressions to end up with 6. Saying this, is the same thing as saying 6. Again, 12 does not have a, if one of these did have a cube root, you just simplify it right there. But this doesn't have a cube root, this doesn't have a cube root, you multiply them both, the result does have a cube root, and thus we apply the cube root, okay? Now let's look at the rules of the division. They tell me that 4th root of 80 over 4th root of 5. Again, 80 doesn't have a quartic root or a 4th root. 5 doesn't have a 4th root. However, if I do this, again, just like the multiplication, the exact same power of the root, I can just put these numbers inside together. You can break them apart or put them together. Sometimes you'll be doing this, sometimes you'll be doing this. Much like multiplication, sometimes they're going to give you two different things. You got to multiply them and then apply the root. And sometimes you'll see we're given a root and then we have to break it up so we can simplify at least part of it. You'll see how that works. Now, when you divide 80 by 5, you get quartic root of 16. And the answer of quartic root is 2. 2 times 2, 4 times 2, 8 times 2, 16. So saying this is the exact same thing as saying 2. And that's what we want to do. That was example 2, by the way, on page 245. Now let's go over example 3. It says cube root of 135. Example 3 tells me to express this in the simplest form. That just means simplify, take whatever you can out of the root. Okay. Now, the easiest way to do this is by doing the tree that I taught you guys. That's how I do it. So I begin with 135. I cannot divide by 2. I can divide by 2, so I continue. 3. This can be divisible by 3. How do I know? 5 plus 3 is 8, plus 1 is 9. 9 can be divided by 3. This number can be divided by 3. And the answer is 45. 45 can be divided by 3. 3, 15. 15 can be divided by 3. 3, 5. 5 can no longer be divided by 3, so I divide by 5, 1. We always put the number we're dividing by on the left-hand side and the answer of the division on the right-hand side, and we want to end up with 1. The sides are important because at the end, we're going to find these things, and these are our factors. So cube root of 135 is the same thing as 3 cubed, which is 27, times 5. 27 times 5, 135. And now what do I do? Easy. Remember, think of this like a gate or a toll booth. This is what the toll costs. This is how much money you have. Can this guy cross the toll? Yes. How much money did he pay? $3. How much does he have left? Nothing. But in this case, nothing is a 1. Because even though nothing would be 0, any number to the 0 is 1. We'll see that later. And on the inside, the 5 can't cross the toll because it costs $3 and he only has $1. So that is the simplest form of this expression. 3 cube root 5. Again, do the little tree, list your factors with the proper exponents, take out whatever you can from the root. Okay. We're not gonna work on example B yet. We're gonna do that. We're gonna do example 4 also when we're together because that's using the conjugate. I don't want you guys getting confused. Now let's jump over to example 5. Let's go over example 5. It says adding or subtracting like radicals and roots. For 10 plus 7 quartic root 10. Now, when you're adding radicals, you can substitute identical radicals for a value x just to help you visualize. So this is quartic root of 10, this is quartic root of 10. They are exactly the same. I'm just gonna change them for x like you normally do in algebra. When we add these two, x plus 7x, you get 8x, and then you can substitute your x back for this, quartic root of 10. Basically, this is like adding variables. When you're adding variables, note that the variable doesn't change. The x doesn't change. Only the coefficients change. When you're adding or subtracting, you do the proper operation on the coefficients. 1 plus 7 equals 8. Same thing applies for subtraction. Same thing applies for subtraction. Minus 2, quartic root of 10. 1 minus 2 is negative 1, quartic root of 10. So again, adding or subtracting, the radicals don't change. They have to be identical, both the power and what's on the inside. Both. They have to be identical. Add or subtract the coefficients and done. That's all you have to do in adding or subtracting these kinds of radicals. That's example 5. Example 6. They tell us simplify the variable expression. Again, now we have a slightly more complex expression than we did previously because now we're given a number and a variable. Again, for the number, we can do the little tree. 2, 32, 2, 16, 2, 8, 2, 4, 2, 2, oh my God, 2, 1. I almost ran out of room. So 64 is 2 to the 1, 2, 3, 4, 5, 6. So let me change my 64 for 2 to the 6th power. Let's see if it's true. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. Perfect. And what I recommend is just copy the variable exactly as is currently. And now let's do the toll booth. Costs $3. This guy has $6. 2 cars can go through, basically. So 2 cars can go through. This guy has $6. This costs 3. 2 of them can go through. There's nothing left inside, so that goes away. 2 squared is 4. So simplifying the previous expression, I'm left with 4y squared. That's it for example 6. Again, you could try doing example. Let's actually do example B. I want to do that example as well. When we look at division, we have quartic roots of x to the 4 over y to the 8. Note that in this division, the variables are different. So I can't just go ahead and cancel or simplify. What I'm going to do is, to make my life easier, I'm going to split it up. I have this right now, one radical that has both variables inside. I'm going to turn it into this. So I'm going to have quartic root of x to the 4, quartic root of y to the 8. This guy can come out once, he pays the toll once, so I'm left with pretty much x. This guy can pay the toll twice, it costs 4, and he has $8. So I'm left with y squared, pretty much. That's it. Break it down and then work each one individually. Example 7 is pretty much just a longer multi-variable system. We do the exact same process. Just simplify the number and use the toll for the variables. Okay. Now this is incredibly important. This is the most important part probably of today's class. We're mixing everything we've learned in order to work properly. Por ejemplo, let's see. Let's look at the first one. Again, to remind you guys, To remind you guys, this is an addition, so the radicals have to be the same. They are the same. So what do? Add the coefficients. And done. Pretty straightforward, pretty simple. The problem is, as always in math, things start getting a little bit more complicated. So what the book does a lot, and what's going to happen on the test is they might give you different expressions, such as this. Now, when they give you expressions like this, note that this radical is different than this radical. I have 2z to the 5th power, and here I have 54z squared. Neither the coefficients nor the variables are the same. When this happens, you have to simplify both sides. You have to simplify this, even though it looks like a very small number. You can still simplify the variable. You also have to simplify this. Let's simplify the left-hand side first. The 2 can't go out, only has $1, costs 3 to go out. The z, one of them can go out by paying $3, and I will have $2 left. Sorry, that's a cube. So I have 2z2. 1z came out, paying $3, I have $2 left. Minus, now let's simplify this. The 54 divided by 2 is 27. I can't divide the 27 by 2, but I can by 3 is 9. By 3 is 3. By 3 is 1. So 54 is 2 times 3 cubed, oh, this is a cube as well, times z squared. The 2 can't come out, the 3 can come out, the z squared cannot come out. So again, I'm going to copy everything again, and I'm going to take away everything that I can from inside the radicals. In this case, again, the 3 came out, I had a z there, and inside the parentheses, I'm left with this. Now, if you focus, or if you pay attention, you can see that now the radicals in their simplest forms are the same. Since they are currently the same, all I gotta do is this operation with the leading coefficients. 12z minus 3z is going to be 9z, and then you just copy your radical. Oops. And you're done. Again, you can see when you add the radicals, they don't change. Again, you always have to simplify first. Simplify first. I took the z cubed away from here. I took the 3 away from here. I ended up with the exact same radicals. Now I just do the operations with the leading term. Boom, done. Now that's the most critical part of the class, adding and subtracting radicals that are different. So right now, what I need you to do is the following exercises. Give me a second. Okay, I need you to do 65 from 65 to 70. Remember, do it today, turn it in before 10 p.m. 65 through 70, and also '57 through 60. Note, in these exercises, some of the denominators, remember, have variables with negative exponents. You just pop them up. Anytime you see a negative exponent, you flip it, turn it positive. That's it. Remember, the number stays the same. If this is negative x negative 1, it's still a negative x, only the exponent is now positive. Make sure you get these problems done. And remember, if you think you might benefit from having Fridays to just video conference particular students. It's not going to be the whole class. Say, Profe, I need to have these questions answered. We can set up a video call to just answer all the week's questions in a real-time fashion, not just via chat or voice notes, which is doing a good job so far, but maybe you might need or want that interaction. So let me know on the chat if you might benefit from perhaps setting a day a week apart to just do a lot of exercises. Again, it's not going to be just, oh, no video today, we don't have to do anything. No, we're switching the video to exercises that are critical. I can select very particular examples from each of the week's class. You can work on them and then let me know if you have questions. Other than that, keep on doing a good job, guys. I believe most of you are doing your work properly. I think you're learning. So just, keep on working. Let me know if you have questions. Have a great day.